Hey, and welcome back to Probably Optimal. In today's video we want to start looking at the fundamentals of probability theory, and at the very basis of probability theory is the so-called probability space omega AP, which is the formal mathematical model for an experiment. In particular, today we want to look at the so-called sample space omega, which subsumes all possible outcomes of the experiment. And if you're only interested in the definition, that's basically all there is. Omega summarizes what can happen if you run the experiment. And since it's typically not too hard to get sample space right after you have seen some examples of it, this is exactly what we're going to do in this video. To get started, let's have a look at a few typical textbook examples, namely experiments that only have a finite number of possible outcomes. For example, if you toss a coin, you usually assume that the coin can actually only land on heads or tails. Therefore, in the mathematical model, you typically exclude all other cases, such that the sample space omega would be the set heads and tails, which you can mathematically also simply represent as the set 0 and 1. Similarly, if you roll a die, you would model omega as the set of numbers 1 to 6, and therefore assume that it's not possible that the die can land on a corner or an edge. And finally, if you draw a card from a deck of cards going from 2 to aces, all the possibilities are simply all the cards, that is, omega is the set going from 2 diamonds up to ace clubs. And again, as these are 52 different possibilities, you would mathematically simplify this to the set 1 to 52. Now, what changes if you have an experiment that runs sequentially and involves several steps? For example, if you have 3 coins that you toss sequentially. In this case, omega has to include all possible combinations of all possible outcomes of each of these single steps. Therefore, we have to take the product between them, such that omega is the threefold product space of the set 0 and 1. To give you an intuition why the product space is the correct choice here, simply imagine what can happen in each single step. In the first coin toss, we have 2 outcomes, which are represented by 0 and 1. Then, for each of these 2 cases, we have again 2 cases for the second coin, such that we have 2 times 2 possible outcomes for tossing 2 coins. And finally, when we toss the third coin, we have again 2 more possibilities for each of these 4 cases, such that we end up with 2 to the 3 or 8 possible outcomes. After having seen this simple sequential experiment, it's probably easier to see how we would model a Markov chain on a given graph, which can serve as a model for a whole variety of experiments, most prominently as how a user would traverse through the internet. In this case, in each unit of time, the user can possibly be at any of the nodes of G. That is, in each unit of time you have to represent the whole graph G, such that if you run this experiment for capital T time steps, you would have to model the sample space omega as the t-fold product space of G. The next experiment is for anyone working with data. Here, a common task is to do regression, that is, approximating an unknown function f based on a given data set of observations from it, where the data set typically consists of x values in some space capital X and corresponding y values in some space capital Y, which you can, however, only observe with some random errors. In this case, the random outcomes of the experiment is actually the data itself, which consists of n tuples from the product space of capital X and capital Y, such that omega would be represented as the corresponding n-fold product space of x and y. As next example, you could be looking at experiments whose outcome can be any point in a subset of the two-dimensional plane, in which case omega is simply this subset. For example, you could be interested in modeling shooting a bullet onto a target. In this case, the subset of the two-dimensional plane is the target, which you could represent as a circle with a certain radius r, such that omega is the set of all points lying inside the circle. As before, this would correspond to making the assumption that the bullets actually can only land on the target and not beside of it. Final experiment, I want to look at stochastic processes taking values in the real numbers. For example, you could be interested in modeling the stock price of a certain company over some period of time t. In this case, in each unit of time, the stock price can lie in R, or, if you prefer, in the positive real numbers. Since we want to model the whole sequence of prices over time, that is, again, a sequential experiment where each outcome of our experiment is a sequence of prices, we need the corresponding t-fold product space R to the t. Here, depending on what you actually want to model, t could be a discrete set of time points, in which case you get a discrete time stochastic process as, for example, for daily prices, or it could be a whole interval in R, in which case you would end up with continuous time processes. With that, we are at the end of this video. I hope you liked it and you could learn something from it, and thanks for watching.